Hello, everybody. Thank you for joining this tech talk on Amazon HealthLake. Today, we are going to talk about making sense of health data with Amazon HealthLake. I'm Sridhar Ramachandran. I'm a senior product manager in the Health AI team. I'm the product manager for HealthLake. I have with me today also Mirza Beg. Mirza.
Hello, everyone. Mirza Beg. I'm the Principal Solutions Architect on the Health AI team, specializing in the HealthLake Comprehend Medical services. Back to you, Sridhar.
Thank you. So let's get started. Amazon HealthLake. What is HealthLake? Amazon HealthLake is an AWS service that enables end-to-end storage and analytics service that helps normalize healthcare data for data interoperability, analytics, and AI/ML. HealthLake is a fully managed HIPAA-eligible service and organizes the health data in a data store. With HealthLake, you can extract medical information from unstructured health data, query HealthLake data using SQL, and perform analytics and ML integrated with QuickSight and SageMaker. So let's explore some of the key benefits of HealthLake. First, HealthLake supports interoperable standards like the FHIR standard format, that's Fast Healthcare Interoperability Resources format. Interoperability ensures that health data is shared in a consistent, compatible format across multiple applications. Amazon HealthLake creates a complete view of each patient's medical history and structures it in the FHIR standard format to facilitate the exchange of information. Second, HealthLake transforms data seamlessly to automatically understand and extract meaningful medical information from raw disparate data, such as prescriptions, procedures, diagnosis, revolutionizing a process that was traditionally manual, error-prone, and costly. And third, HealthLake identifies trends and makes predictions. HealthLake presents a chronological order of medical events so that you can look at trends like disease progression over time, giving healthcare organizations new tools to improve care and intervene earlier. Healthcare organizations can build machine learning models with Amazon SageMaker to unlock novel insights, find patterns, and identify anomalies. Healthcare priorities are changing. When we talk to healthcare customers, we hear about a growing list of challenges. Patients today have more data collected on them than ever before. Making sense of this data is critical. There's a growing need for integrated diagnostics, uniting imaging, lab genomics, wearables, and longitudinal data for actionable insights to deliver the patient 360 view. HealthLake makes it easier with one-click data store to migrate your on-premise FHIR files to an S3 bucket and then index all of your health data in the data store. The data store creates a complete view of each patient's medical history in a chronological view and structures it in the V4 FHIR standard format. Customers don't want the burden to create and maintain complex analytic pipelines. HealthLake is fully managed health storage and data analytics service, which enables customers to adopt HealthLake at scale and operate more efficiently and securely. With HealthLake, customers can load their clinical data in HealthLake and have an automated and seamless pipeline to run the SQL queries on that data, build models, create dashboards without having to maintain any more analytical ETL or complex transformation jobs. Customers are looking for secure access and integration of electronic health data so it can be used to optimize health outcomes. HealthLake supports the interoperable standards like FHIR standard format. Interoperability ensures that health data is shared in a consistent, compatible format across multiple applications. Also, HealthLake enables easy share of data with centrally managed fine-grained access controls. Healthcare data is in the form of unstructured medical text like doctor's notes, clinical trial reports, or radiology reports, which contain vital clinical information that customers want to include in analysis. With integrated medical natural language processing, that's integrated comprehend medical, helps you transform the raw medical text data using specialized ML models that have been trained to understand and extract meaningful information from unstructured healthcare data. Customers want actionable insights on their data, which HealthLake enables with the capability to analyze data across HealthLake and other data sources. So let's talk about what the benefits are. HealthLake actually accelerates development cycles, being a fully managed FHIR data store that is operational in less than 30 minutes. HealthLake helps you reduce the time to market with HIPAA-eligible health solutions that uses AI/ML uh, analytics to provide insights into the healthcare data. Healthcare is a domain-aware data store. That's a health data-aware data store supporting the FHIR standard for APIs and data resource schemas, a common standardized industry-accepted schema enabling the FHIR or FHIR-based application compatibility and efficient sharing of data with both internal and external stakeholders. With the integrated ML medical NLP or the integrated comprehend medical, you can automatically extract entities. For example, medical procedures, medications, entity relationships. For example, medication at its dosage, entity traits. For example, positive or negative test result, time of procedure, and protected health information, what is known as PHI, from your medical text without changing the data you receive. Fully managed health storage and data analytics service enables reduction in total cost of ownership for maintaining complex analytic pipelines and transformations. We also are making sure that AWS services are integrated and provided together. HealthLake makes the data available to the services such as QuickSight and SageMaker for healthcare analytics and machine learning solutions. Further, to drive the point home, we have here a representation of a typical architecture for analytics. Technical teams invest a lot of time in building this complex architecture and maintaining it. Typically, healthcare customers have to maintain complex analytic pipelines and transformations from multiple datasets and data models, which are time and resource intensive. With HealthLake, customers can load their clinical data in HealthLake and have an automated and seamless pipeline to run SQL queries on that data, build models, create dashboards without having to maintain any more analytic ETL or complex transformation jobs. It therefore gives back time to customers to focus on other product features that can add value to the product. Now that the data is all indexed, it's structured, it's in a chronological order in the cloud, it becomes more useful to specifically know what's going on right now and predict what might go on in the next several years and to target wellness. You can explore trends about your patients or population, personalize care at the individual level using QuickSight. You can build, train, deploy ML models with SageMaker to make predictions earlier than would have previously. So that way you can intervene and more quickly to improve care and reduce costs, such as predicting patients' risk of heart failure or sepsis, or optimize and improve patient flow. You can also easily share and access their data in a secure, compliant, and auditable way using standard APIs like create, update, delete, search, read, export. And with managed keys, GDPR compliance, and HIPAA eligibility, you can be confident that the patient's data remains secure and their privacy is protected. With that, let's look at some of the use cases that HealthLake enables for specific industry segments, starting with payers. Imagine you have all of this data for all the Americans living with diabetes. With HealthLake, you can bring together these hundreds of millions of data points to paint a picture of the entire diabetic patient population. As an example, with powerful query and search capabilities, you can identify a subset of patients with chronic diseases, such as uncontrolled diabetes and high blood sugar levels, to address complications early and adjust treatments. And finally, you can use tools like Amazon QuickSight to create an interactive dashboard to compare the subset of patients with those in a similar situation to identify anomalies, or build Jupyter notebooks in Amazon SageMaker to identify those diabetic patients that are increased risk of future complications from high blood pressure to blindness to heart disease. HealthLake offers ability to create patient phenotyping or longitudinal medical record that can power insights for risk, quality, utilization management, and beyond. It can predict low med adherence. That's low adherence to medication in chronic disease patients leads to increased morbidity, mortality, healthcare costs. In combination with the EHR records, HealthLake enables you to identify patients at risk for non-adherence and provide more targeted and effective interventions. With providers, similarly, here are some use cases that are unlocked for providers. For instance, prevent ER diversions and overcrowding. With the leveraging the patient data, EHR data, clinical claims data, you can predict length of stay, emergency department arrival, ER admissions, aggregate discharges, total bed census, and that leads to reduced patient wait times and then prevents diversions and overcrowding. Patient risk identification, using the data from the patient's historical records, daily evaluations, measurement of the vital signs in real time, such as heart rate, blood pressure. Staff can be alerted to imminent patient risk so that immediately they can take preventive actions. Chronic diseases like cancer, asthma, heart, and lung diseases have severity episodes that can result in ER visits. HealthLake can enable you to predict the risk of severity of the disease and alert the provider to intervene and prevent the severity event. Medicare payments are linked to readmission rates, and failure to address this issue can be costly. Providing clinicians with daily guidance as to which patients are most likely to be readmitted during an inpatient encounter helps them plan and intervene. For example, by keeping the patient in the hospital longer to reduce that risk, you can use HealthLake to identify readmission risk patients. Similarly, HealthLake as an HIE platform opens up multiple interoperability use cases, such as a FHIR-enabled rapid viewer on HealthLake to visualize health data using comprehend medical processed information linked to medical ontologies like SNOMED CT and ICD-10 to enable analysis. HealthLake's FHIR specifications enables greater precision in retrieval of data to build a patient's full health record. HealthLake helps advance interoperability between primary care providers and specialists. When a PCP refers a patient to a specialty provider, the relevant health information is accessed to help the specialist manage the patient needs. If a provider has recently done tests on the patient, there's no need to redo the test. That reduces cost. The patient also does not have to go through the inconvenience and discomfort of another test. HealthLake also enables querying on HealthLake data to improve care coordination between the shared patients. Care coordination, for example, care coordination for surgery between orthopedic specialty provider, hospital, and home care, or care coordination between PCP and behavioral health provider, or hospital labs and home health agencies. For life science and pharma industry, HealthLake enables use cases such as discover the patients eligible for clinical trials. Eligibility criteria are an important part of clinical trials. Participants in a trial are alike in terms of specific factors such as type, stage of cancer, general health, previous treatment received. For rare diseases, getting participants is a challenge. And for patients with rare diseases, knowing of a trial that they may be eligible to participate could be challenging. Real-world evidence, RWE, can come from a number of sources. EHR claims. Real-world evidence is the clinical evidence regarding the usage and potential benefits or risk of a medical product derived from the analysis of real-world data. There are multiple use cases where real-world evidence is needed, and HealthLake enables you to support that. At this stage, what I'm going to do is I'd like to introduce Mirza again and bring him in to demonstrate HealthLake and showcase some of the features that I spoke about earlier.
Thanks, Sridhar. You covered a lot of items and capabilities that HealthLake offers. So what I'm going to do is basically cover these 6 points from a HealthLake demo perspective. Before I get started, I just want to make sure that whatever data I'm going to show is going to be synthetic. I just want to make that disclaimer and does not include any PHI. So I'll cover these 6 items. I'm going to first make sure that I address the fact that HealthLake is part of the overall AWS ecosystem. That's number 1. Number 2, Sridhar mentioned FHIR and FHIR R4 and FHIR data model several times. I want to make sure that what does that really mean from a data perspective? I want to spend some time on that. Talk about data ingestion and show that to you in terms of how that works and what happens when it lands in the AWS HealthLake zone. the ETL processes and queries that you can run, and then connect the dots with comprehend medical and of course visualization as well. So this is the overall context of the where HealthLake potentially reside in. HealthLake, if you notice here, is actually right here, right? It's a data store that is FHIR enabled. But if you start from the left hand, lots that you are actually bringing in to the ecosystem, and you have multiple ways to bring it in. Sridhar mentioned APIs, certainly. You can also do a bulk import jobs, for instance. Depending on where your data resides, you can use the data migration services or data sync or even streaming via Kinesis, for instance. So you could do all those, and you can bring all the data that you have from a variety of different formats like HL7 or CCDA or XML or JSON or even X12 from a EDI 837, 835 perspective. We have third-party tools. We have some tools available natively. You can bring all of that in, and then you can parse it here. You can bring it and store it within the HealthLake in a FHIR data model. And then you can put a governance layer, a quality layer, a metadata layer for that data, conjoin it with a variety of other tools, Athena, EMR, etc., from a query perspective. And then once you have the discrete data available, you can also obviously leverage that to run your ML and AI models as well, and then expose all of that through a variety of different mechanisms as well is on the right-hand side. And you can orchestrate that with the familiar tools that are available out there from a monitoring perspective, from an orchestration perspective, and notification perspective, right, with SNS, and certainly with CloudWatch or CloudTrail, et cetera. So I just wanted to make sure that you all understand that HealthLake is part and parcel of the AWS ecosystem, the 200 plus services that are available within AWS, and the 120 plus HIPAA eligible services, because we're talking about healthcare, that are also that plays well with HealthLake. So let me go switch over to the demo. And then on the demo side, what I'll do is actually start with the console. And I'll start with the assumption that data is already within your S3 bucket. So you brought in the data into your S3 bucket. And within that S3 bucket, you have parked it in a specific folder. And if you notice, these are all different resource types. If you're familiar with FHIR, FHIR has 145 plus resource types. And each one of them stores the relevant information within those resource types. It's a common data model, meaning it's used similarly across implementations vis-a-vis FHIR. Of course, there's always room from an extensibility perspective because FHIR does allow for extensions and so on and so forth, which I'm not going to get into in this particular talk. But just be aware that this is a FHIR common data model, R4, and all of those resource types, and those resource types are generally available within HealthLake. And if you notice, once you bring it into the S3, you notice that the format is ND-JSON, new line delimited JSON format, which essentially means that there's a new resource on each of the lines that are represented within that particular file. So once the data is in, you essentially run a job, bring it into HealthLake, and from HealthLake, you're now able to basically go and start running and basically analyzing your data. So I'm going to do that. I'm going to go into a specific health store. And within that health store, you can see that you can bring it in from an import perspective. These are bulk APIs, import and export. The import would basically point to the S3 bucket that I just showed earlier. But I'm going to go into the query piece of it just to sort of show you and make sure. I'm going to do a search with the get, and I'm going to do it for a patient because patient from a healthcare perspective is the center of the universe. And I'm just going to limit it to one just to make sure that the query is not running and fetching all the data, right? So here's the actual FHIR JSON response, right? This is referred to as a bundle. Bundle potentially includes a variety of different resource types within each. HealthLake, of course, supports bundles as well. But the actual resource type that we're interested in is in the patient. You have the ID represented there, and so on and so forth, right? Again, generic FHIR JSON package, right? Response includes all the referential URIs that are listed here. This is synthetic data using Cynthia, so you can see references to Cynthia here as well. The various medical numbers, the social security numbers, if they're available, driver's license, and whatever else is available within that particular patient. So that's their nested JSON, and then that's all within the HealthLake data store. What I'm now going to do, and by the way, this particular query string, you can put that in Postman, you can put that on your third-party applications, and basically do a CRUD API, right? You could do a create, update, etc. vis-a-vis, and obviously the count would be just, this is for a specific get here, but you could easily insert and create and do a post, right? But up to here anyway, this is pretty generic almost. And then the one would be the one post that would be a bit different depending on your use case. So I'm going to do one more from a document reference perspective, because document reference is important simply because that's the resource type that unstructured data rather is stored in. So I'm going to again do a simple document, one document rather, and bring in document reference, right? So this is unstructured clinical note that was brought in a JSON format, FHIR JSON format, and is now stored in a FHIR resource type document reference. And you can see here that Comprehend Medical has already done its job in the sense that it has identified the various entities and associated with the various ontologies as well, like ICD-10 concepts and so on and so forth, right? The entity here is the medical condition, and the condition is tied to an ICD-10 code. And you can see confidence scores as well. One of the differentiators for Comprehend Medical is that you actually get the confidence score as part of the response. So you have transparency there, and you can use that when you're doing some analysis later on for an ML perspective, let's say. But the one area that I wanted to delve into here is actually in the body of the text that was used to analyze it. And it's here. I just have to find it. I'm just scrolling down here. So basically, the original text that was used to create this particular package is actually should be coming up anytime soon here, right here. So this is the content. This is the original clinical text that was inserted. And what it's done is basically parse all of that data. And this is obviously base 64. And what I've done is basically, because this is synthetic data, I'm using an online tool just for illustration perspective. I've just gone to an open website here and just typed in or just copied this particular base 64 format. And this was the original from a decoded perspective, right? Chief complaint, history and patient of illness, social history, and so on and so forth. So you can see from this information, a hell of a lot more information was actually gathered and parsed and made sense of, right, as it was brought into HealthLake. So I'm going to move from the raw data store that is Amazon HealthLake to a new capability that we have available as well, coming up rather, and that's on the Athena side. Athena, as you know, you can use that as a query engine to query a whole host of data but you can also include that you can also use that for querying HealthLake data. So I'm just going to, since we did mention document reference, I'm simply going to go to document reference, and I'm going to bring in that, run a query to say, fetch me all the various things associated with document reference. I can see I've just limited it to 5 here. You can see that all the various data is now in there. But you can also notice that this is also still fairly nested, right? Which from an analytical perspective starts to starts to accumulate. On the left-hand side, by the way, before I go into how you actually unnest it, are all the various tables that were part of my HealthLake data store, plus a couple others that I've added since. But since we're on document reference, I'm just going to go here again, and I'm going to show you that these are the various within that particular table. So it's extracted the information from HealthLake using Amazon Glue and is now representing that within Athena, or you can query it within the data catalog that AWS Glue had created for this particular database, and is now being referenced here from a tabular from a table slash columnar view. And you can see that some of these are strings, some of these are arrays, some of them are structures with arrays in there, and there's array with a structure and an array. So fairly deeply nested, right, from an overall perspective. So again, the question that you may have in mind is, okay, well, this is fairly nested. What do I do with it, right? And what you can do actually is quite a bit, because with the ability to leverage SQL on FHIR, which is the ability for you to essentially unnest that data and bring in discrete components of that data out, you now have the full power of SQL available to you. So this is, I'm just doing this for illustration purposes. I'm going to go to the patient, and actually I'll go to the condition, since condition is referenced more here in this particular query. And you can see that a variety of different data types are mentioned here. Excuse me. Well, format types, but also a variety of different columns and data is represented here, right? Some of them are just generic strings, but some of them are arrays. And within arrays, like for instance, like if you look at the code, right, you have the condition/code, condition.code rather, you can then start picking up specific items in that array. It starts at 1, not at 0 here. So condition.code.coding 1 and display, which is the display of that particular code, and then get that represented. And what you now have done is basically start nesting it into discrete data elements, right? You have the patient ID, you have the name, you have the first name, birth, date of birth, and so on and so forth. And what was the condition text display there, and the associated code with that condition. So again, you have a lot of flexibility as you're traversing this particular, as you're playing with getting data out, analyzing the data set that you have, and so on and so forth. The other thing I want to also bring up here is that you can also, you're not just limited to HealthLake data store. You also can join other data sets that are possibly within S3 or some relational RDS or Aurora for that matter, and then bring that in as well. So what I've done here is basically downloaded the NPI text available as part of NPPES for US nationally, which has about 1 million records or so. And basically it's asked the question that whether the NPIs that are referenced here as part of the synthetic data, if there's a match of that particular NPI within the real data set, which is downloaded from the CMS website, all right, those 1 million records. And of course, the answer should be a no. And if it's fake, represent that as fake. And as you can see, these are all fakes. So the point I'm trying to make here is the capability for you to be able to conjoin data sets, external data sets, Athena, by the way, also has lots of connectors that you can leverage for third-party tools like Snowflake or other platforms, and then conjoin that with the data lake that the data store that you have within HealthLake. So that's that. I'll quickly move over to QuickSight, just to again illustrate to you the capability that's available. So now that you brought it into FHIR S3 bucket, you are now representing that in HealthLake, and from HealthLake, a glue job was run, which then brings over discrete data sets into Athena from a query perspective. And then from there, I'm moving over to QuickSight. And within QuickSight, I've basically done two canned reports, or I've created two reports simply because of time, to again show you the power of the possible, the art of the possible. Here, what I've done is essentially created a longitudinal patient record to say what patient came in, what date, what was the condition enunciated there, and so on, right? So you now have, from that FHIR data set, you have essentially brought over, you can do that with claims, you can do that with, so basically you can bring in clinical and financial data and conjoin the two and represent that here within QuickLight from a dashboard perspective. We've also done a word map here to say what, from my population set, what are the main conditions. And then I've also done who are my most, who are the patients that have the most conditions, right? So Parisian 65, for instance, has 6, and so on and so forth. So that's, again, plenty of possibilities here. I wanted to just show you the art of the possible. And I'm going to end with 2 graphs related with Comprehend Medical and the fact that you now have discrete data from unstructured text stored in HealthLake that is now being queried and analyzed through QuickSight. So I'm looking at the entity score. There are 2 levels of scores, by the way, in Comprehend Medical. One is at a top layer at the entity level. There are 6 types of entities. And then within that, what are the various ontologies and what the confidence scores are. So I'm just looking at the entity score by the parse condition. And I'm looking at what were the predominant conditions and within my population set, right? So conjunctivitis and so on and so forth, right? Again, fake data, population data. So the data may not make sense, but again, the art of the possible here. And then what my histogram looks like from an overall spread perspective, right? In terms of what is my distribution in terms of entity score, meaning are my clinical notes accurate or exact enough for it to be able to be parsed by a machine, let's say, right? Or how good, so basically the contextual text associated with that, right? So you can see that 0.80, 1 being the highest, right? And above is there's a decent amount, a large amount of folks, clinical notes that have been identified with that confidence score. So you can do this, by the way, you can bring in data into SageMaker as well and analyze it and run your ML models as well. So I just, again, wanted to show you the art of the possible throughout that life cycle. The generic use case, and then perhaps in the later sessions, we can delve into other possibilities as well from a capability perspective. So with that, what I'd like to do is actually end here and pass it back to Sridhar for some closing slides and comments. Sridhar?
Thank you, Mirza. So as a reminder, Amazon HealthLake has partners who can help you get started quickly with a range of Amazon HealthLake applications and services. To start, if your data is not yet in the format you need, like the FHIR format, you can work with the Amazon HealthLake connector partners who help you transform the existing healthcare data into a required format. Also, if you want population or patient health record viewers with the FHIR data, you can work with health record navigation and viewer partners with solutions built on Amazon HealthLake. Also, here are some collateral links for more detailed documentation and workshop, which is displayed here on this slide. Thank you, everybody, for your time. Feel free to reach out to us for more questions. Thank you.